me start the recording. Sorry about that. That have to be removed by the air conditioning, which uses energy. So if we engineer a high performance lighting system, then we need less mechanical, less cooling to take care of that, right? High performance other building systems, air conditioning, ventilation. We also want to look at free sources of energy such as daylighting or air-to-air heat recovery. A good energy strategy, again, in commercial design would be daylighting. We want to get that natural light as deep into the floor plate as we possibly can. We want to do it in a way that reduces glare, right? Yeah, we can bring natural lighting in, but if it's glaring and not well controlled, then it'll be uncomfortable for the occupants. So we want to bring light in, but also control it to reduce glare. And then we have to combine it with our daylight harvesting or daylight controls to dim the lights when natural light is available. Again, I show some examples of different strategies to allow us to bring daylighting into the building. Again, air-to-air heat recovery is a good energy strategy. We saw that in the picture of the passive house, right? So this is, we've made the building envelope tight. We've reduced infiltration or uncontrolled air leakage, and now we have to have controlled ventilation to provide for the needs to provide fresh air to the building occupants. And we typically want to try to do that with a air-to-air heat recovery system where we use that warm air that's being exhausted out of the building to preheat or pre-cool air that's being brought in to replace it. Again, general energy strategies. Building modeling or energy simulation, typically something that would be done in a larger, more complex commercial project. You're going to build design the building, and there'll be someone on the design team who is a modeling specialist who will take that model and try to predict how much energy the building will use, and that model or that prediction is then used to fine tune some of the design strategies, do some what ifs. What if we did this? How's that going to impact performance, right? Those what ifs will be brought back to the design team, and they'll work on kind of an iterative process to improve the building performance. We talked about commissioning. We can also have what's called monitoring-based commissioning, where we use that data to verify and hopefully improve performance on an ongoing basis. And again, on an ongoing basis, we want to make sure that we adhere to the OPR or the requirements that the owner put on us as a design team, make sure we've delivered the program to the owner, and that we have good training so the people that have to operate the building understand what we as a construction team wanted to achieve. And hopefully we haven't made things too complicated, that we can train the people who have to run the building. They have to do the preventative maintenance. They have to make sure that all the systems are taken care of. Another thing that's common in green buildings is some kind of informational display or kiosk sometimes, where you have a display that gives some feedback to the building occupants in terms of how the building is performing and what they can do to contribute to the performance of the building. So again, we've talked about this before, beyond LEED, right, where our goal now is to getting to net zero or carbon-free buildings. We've talked about this already, greening the grid, net zero energy, building electrification. Right? How do we get to net zero? We have to dramatically improve the energy efficiency of all the building systems, by the shape and size, the construction of components, the details of the billing envelope, operations and maintenance. And then once we do that, then we have the ability to address those remaining needs with renewables, on-site potentially or off-site as well. In the last couple of years, there's been more work done on energy codes, right? Remember, energy code would be the minimum requirements, the must-have, the things that we have to do. So again, zero code is one commercial energy code put out by Architecture 2030, model building code that supports net zero buildings. So again, design an efficient building and address the remaining building energy needs with renewables. The same thing is happening in the residential space. Sorry, this is a little bit of a busy slide here, but the point again is that various groups are working on more stringent standards that, if adopted, can help drive us towards net zero performance. So again, a building code is something that has to be adopted by the local community. So again, part of the way that this gets driven is that, local jurisdictions, adopt some of these building codes and standards that have more and more stringent requirements, right? That helps move the marketplace in the direction of high performance net zero buildings. Right, again, we have building codes and standards. Building code is mandatory, we must do it. So to reduce CO2, these aggressive standards that drive toward net zero must be adopted by local jurisdictions. So, part of our challenge here is that we have to get all the Village of Oak Park and the city of Cicero and Berwyn and all these towns and municipalities and jurisdictions to, adopt these more stringent codes to help drive the construction in their jurisdiction towards the direction we want to go in. Part of it we as professionals also need to do, right? We need to learn all this stuff so we can deliver these sorts of projects on a cost-effective basis for our clients. Right, sorry for a lot of words on the slide here. We talked before about electrification. Right, electrification means to get the fossil fuels out of our buildings. Right, take the gas-fired boilers and furnaces and stoves and ovens and dryers and convert those to things that are on electricity. So that, in conjunction with greening the electric grid, is how we drive carbon out of our buildings. Right, with energy efficient windows, heat pump dryers, electric vehicles, heat pumps, induction stoves. Right, I wish we kind of pre-COVID, we used to do a tour of we had a homeowner in Oak Park who has done many of these things, and it was very interesting to go in their kitchen and look at their induction stove and have the homeowner talk about how the induction stove worked. It was pretty interesting to me. Hopefully, in some future year when this COVID stuff is behind us, we can go back and visit their house again, because it was very impactful for the students. I'm sorry that we haven't been able to do it for you, and I haven't been able to do it in the last couple semesters. Right, so again, electrification, heat pumps, making the envelope more efficient, heat pumps, other ways of meeting the heating and cooling needs of buildings with electric technology, and tying that to a greener electric grid. Again, I've showed the same, the same sort of thing in a number of different images, but everything's kind of pointing in the same direction. Okay, any questions on LEED credit category EA? Okay, I'm going to switch gears here and give me a minute to switch slides. We're going to move to, oops, I can't shut my mic off. We're going to move to lead credit category MR, or materials and resources. So give me a second to switch that. Okay, well, just like I did with EA and some of the other credit categories, I'll have, in this case, a lecture here that will maybe partially get through tonight, talking about some of the underlying concepts, and then next week we'll bring those concepts together into the details of the lead credit category. So we're going to talk about C&D waste, or construction and demolition waste. Right, I think I've showed this image before, right? We for the most part have a linear system of resource use. You know, we dig stuff out of the ground, we turn it into products. You know, we move those products, we distribute those products from the factory to the warehouse, you know, to the Amazon Prime, you know, shows up at our house in the UPS truck. We use that product, and then when we're done, we throw it away, right? To a large extent, that's how things work now. So that's sometimes called take, make, waste. But there's, as you see, some flaws in that model. You know, as we've learned this semester, right? Our Earth's supply of resources is not infinite, and certainly the ability of the Earth to accept all that waste is not infinite either, right? The ability of the Earth's atmosphere to absorb all the CO2 that we're putting out in this linear model of resource use, right? We're running up against those limitations. Again, we've looked at this as well. I like to say that, you know, thinking like a forest, thinking about natural systems, gives us some guidance, some ideas that we as designers and construction professionals can take and apply toward the work that we're doing, right? In a natural system, the only energy input is from the sun. All other resources are reused in cycles, and there's no waste, right? When the leaves fall down, they fall on the forest floor, and those nutrients are ultimately recycled and become new trees, right? When a tree falls down or an animal dies, right? All the nutrients, all the embodied carbon in that tree gets turned into something else. So again, we need to start thinking like that. Unfortunately, that's not how we are often operating, right? In our business, we have C&D waste. So what is C&D waste, or construction and demolition waste? It's all the non-hazardous, non-contaminated waste that results from demolition, construction, all the things that we do, right? All the different materials. You just have to think about it. You know, if you're driving around and someone in your neighborhood's doing a project, right? They got a big dumpster parked in front of their house, and all the stuff that's tearing out ends up in the dumpster, right? And in our case, our neighbors across the alley behind us are doing a major remodel of their house, and they have a huge dumpster that's parked, you know, on the pad of their garage, where they don't have a garage, and it's a huge dumpster. So every time that the dumpster guy comes out to pull the dumpster and drop a new one, I worry, because the first time that they were there, the truck driver was sloppy, and he bashed his truck into the beds of my raised beds in my garden. So every time I hear the dumpster guy out there, I have to stand out there and glare at him to make sure he doesn't bash into my stuff again. So again, where does all that waste go? Well, the waste gets put into a landfill, right? Someplace we drive that dumpster off someplace and it gets dumped. And that waste has an impact, right? That waste that we're dumping essentially in a hole in the ground is taking up space. It's polluting our environment. You know, as it says here, landfills are a large source of methane. Methane is a potent or a powerful greenhouse gas, right? So all that waste breaking down produces methane. That methane escapes in the atmosphere. You know, all that stuff we've thrown in the ground. You know, the rainfall leaches toxins out of that and into the groundwater, right? We try hard to contain that by having what's called an engineered landfill. But again, we don't always succeed. We'd be better off if we didn't throw that stuff away in the first place. If we as construction professionals figured out a way to do this better. And while I'm talking here, I'm going to have to realize that I didn't get my links set up for YouTube, so I will do that here while we're talking. Right, so what are some of the impacts of C&D waste? Right, there's a truck almost as big as this is trying to drive down the alley. You know, you saw the picture of my house, right? I live in a small house. You know, drive down the alley and drop that big dumpster in my neighbor's, and I have to stand out there to make sure he doesn't smash into my property. So anyways, right, it costs money, right? Somewhere in the tier of contractors, someone's going to be responsible for paying the tipping fee. We have truck traffic, we have the carbon impact of all that vehicular traffic, we have the pollution, we have the land use, and we have the embodied energy. We have the resources and all that building material that we're discarding. Right, I think Mac just touched on that. Thank you for the introduction. Right, embodied energy would be all the energy that goes into extracting and processing and manufacturing and delivering all those materials to the project site, all the bricks and the concrete and the steel and the drywall and the rebar and the light fixtures and the plumbing pipe, all those materials took energy, took resources. So that's all carbon that's being embedded into the building. Right, so when we tear all that stuff out and throw it away, we're essentially wasting all the energy, all the resources that went into creating those materials in the first place. So what are some of the things we can do? Right, what are some things we can do to impact this construction, demolition, and waste? Well, the first thing is we have to think about, you know, I have the same mantra here: reduce, reuse, and recycle. Right. The first thing is, do we really need to demolish this? Right. And I know our client really wants a new kitchen or a new house or new this and new that, but you know, do they really have to do that? Can we somehow extend the lifetime of this building rather than tearing it down? Can we do something different? Right? Can we repurpose that building for another use rather than tearing it down? Right? We talked about that earlier in the semester as adaptive reuse. Are the materials that are going to be produced, are the materials that are going to be taken out of our project that can be salvaged and reused somewhere else, right? Can we, rather than demolishing, can we deconstruct? And I'll show you a picture of what that looks like. Can we, instead of just going after the project with a crowbar and just ripping the crap out of it, right? Can we take things apart more systematically so some of that material can be reused someplace else? Obviously, we have the option of separating the material out during the demolition, because some of those things in our waste stream can be recycled, right? Chipboard can be recycled, some of the lumber can be recycled, right? So if we are thoughtful about the way we run our construction site, maybe we can recycle some of those materials, maybe rather than having it all go in the same dumpster and get hauled off. Again, what are some things we can do to minimize C&D waste? Right, we can think about where we're actually building. We want to build in a area that's already developed, so we can reuse or maximize the use of existing infrastructure, right, and prevent us from having to build new infrastructure, new roads and sewer systems and sewers and electric lines, right? When we build in areas that are already developed, in brownfield sites as opposed to greenfield sites, we reduce the need to build all this new infrastructure. Obviously, when we get into the design, there's lots of things that we can do to minimize waste. Right now, we're talking about the construction waste. So as a designer, we can design smaller, more space-efficient structures, right? Think about the not-so-big house. We'll look in a minute here at, whoops, looks like some of you are reconnecting. We'll look at more efficient framing techniques. We can design using standard material sizes, right? Design around the modules, 4x8 sheets of plywood, design around sizes so we don't have to cut off and waste stuff. Design for a long service life. But what does that mean? It means that we build a high quality building that lasts a long time and doesn't have to get torn down. It'll have a long service life. We can use high quality, long lasting materials, right? Those are things that we can do as designers and construction professionals. We can design using reused or salvaged materials. Again, as a designer, specify materials with a high recycled content, specify locally sourced materials, specify non-toxic, low VOC materials. Again, the word specify, right? That's if you're an architect or a designer, specify is what you do, right? You're gonna draw plans and write specifications. You're gonna tell the construction team how you want things done on your project, so you can specify these things. But, we have multiple disciplines represented here, both designers and folks who are going to be out in the field doing construction. So it's not just the designer that has a role to play here. It's also the contractors, the folks out in the field. So in the field, you as the architect or designer can provide some takeoffs on the construction documents to give the contractor better guidance in terms of how much stuff he or she needs to buy, right, to prevent that contractor from overbuying. The contractor can make sure that they set up their deliveries correctly, so we don't have materials that are sitting outside and get spoiled, right? Lumber or drywall sitting outside with a tarp on it that gets spoiled and has to get thrown out and replaced. Right? Protect materials stored on site from weather or water damage. Again, possibly save excess or cut materials for use on future projects. That's a little hard. Doesn't always work that way. Return unused materials to the supplier. That may or may not work. Supplier may not want that stuff back. But again, things that we need to think about. So again, renovate rather than demolish. Think about adaptive reuse, build smaller, use less materials, less quantity, higher quality, design for a long service life. Avoid toxic materials and substances, right? Again, I think Mac mentioned VOCs. We want to try to keep some of that stuff out of our buildings. Use locally sourced materials, use reused or recycled materials. So let's look at some of those things in the couple minutes we have left. Right, so deconstruction would be the process of kind of systematically taking the building apart, dismantling it, such that we can reuse some of those materials. As opposed to, again, just taking the crowbar and the saw and just busting the crap out of everything, right? If you deconstruct, then you at least have the possibility of reusing some of these materials on another project. It differs from demolition, where a site is cleared of its building by the most expedient means, right? Expedient means quickest, fastest, cheapest, right? Send the demo contractor in there and just rip the thing down, right? That's how we oftentimes think in our industry, but maybe we need to think differently. We should be thinking differently. Talked about adaptive reuse before, right? Buildings that no longer serve their original purpose. Instead of being torn down, they can be adapted, repurposed to serve a new use. Right? Use a lot less resources than tearing that old building down and building a new one. All the embodied energy in that brick and concrete and steel and wood, rather than being wasted, can be largely retained. Right, you've seen this slide before. Right, what are some of the key features of green buildings? One of them is the wise use of materials. Building with recycled or reused materials, renewable materials, materials locally obtained or near the building site, materials that are not toxic in their production or use. Right, so all the things that we want to think about. Right, renewable building materials, materials that are found in nature and produced in a way where their availability and quantity does not diminish over time, right? So our wood is hopefully going to come from a sustainably managed forest. Excuse me. Right, so that forest, if it's responsibly managed, can grow new trees at the same rate that we as construction professionals are taking those trees down and using them to build buildings with. Right, so we also have other potential renewable building materials: cotton, wheat, sunflowers, natural rubber. I'll show you some pictures here in a minute. Right, in the LEED rating system, we also have what are called rapidly renewable materials, things that grow fairly rapidly, that are renewed in nature fairly rapidly, that we can incorporate in our designs, in our construction. Right, some examples would be linoleum as a sheet good or a flooring product, cork, again, as a flooring product, or a product, a sound absorbing materials on walls. Bamboo is a good example of a rapidly growing, rapidly renewable material. Wheatgrass panels, again, we're taking natural materials and turning them into construction products. Here are some examples of locally sourced materials. We're not necessarily going to have straw available to us if we're doing a project in Oak Park or in Chicagoland, right? We aren't necessarily going to have access to large amounts of straw, but if we're building outside, out in a rural area or out in the country someplace, this may be a material that's available to us. Again, adobe is a good example of a locally sourced material. Right? Adobe is a dried mud brick. Right? It's an ancient building material, been used for a long time. Adobe is most prevalent in the hot arid Southwest. Right? So again, we're not likely to build with adobe in this climate, but there are certain climates where adobe would be a perfect choice. Right, here's another example of a locally sourced material, rammed earth. Again, this is a process where the soil from the building site is mixed with some additional aggregates and basically squashed into formwork. Again, we are less likely to use it here. It's more suitable for other climates. But again, if you're at the right site in the right climate, this might be something to consider. I've showed this slide before. Again, we may have sources of materials that we can use in our building that come from other non-building sources, other buildings, potentially industrial materials, shipping containers, etc. Okay, I've got a couple more videos to watch as part of this presentation, but looking at the time here, we will start off next week with actually a good presentation on design strategies, things that you as a designer can do to reduce waste in your project. So any questions? Okay, well, we will pick this up next week. We're going to wrap up this thing, then I will talk about some specific strategies for LEED credit category MR, materials and resources. Next week will be our last class before the final, so I'm going to also have to squash in IEQ, or indoor environmental quality. Go back and probably hone my presentation a little bit, so I will work on that. And in the meantime, I hope you all have a great week. Hopefully folks are still there. Any other questions?
Thank you.
You're very welcome. We will see you next week, and I'll talk a little bit about the final exam next week, because that's coming up shortly.